Hi, in this video, we're going to take a look at areas in parametric curves. So let's just get to it. Area in parametric curves, you're familiar with the area formula from Calculus 1, and we just have to make a slight modification to this area formula, as you can see here. The area formula from Calc 1 is just the integral of y dx. That's the area between a curve and the x-axis. And so here you can see that the area formula in parametric curves is just the integral of y times dx over dt times dt. Hopefully you see that basically it looks like all we're doing is we're introducing this dt algebraically in such a way that it's equivalent to the original area formula. So essentially you're just going to do the integral of whatever function of y you have times the derivative of whatever function of x you have. So let's go ahead and take a look at an example of this using this cycloid again. I know I love the cycloid, probably because I'm a cycloidist, or maybe a cyclist. Anyway, let's take a look at this cycloid again. And in light of this formula, you're doing the integral of, whoops, that's not working. All right, I think I got things working now. Okay, so yes, that looks good. So what we need to do is we're going to be computing the area between t equals 0 and t equals 2 pi. And this is going to be the area formula is the integral of y dx, which in parametric form is going to be the integral of whatever our function of y is, which is this one, times dx over dt. And then we're doing this whole thing with respect to t. So let me just make this a little bigger for you so that you can see it better. And then I'm going to insert the functions themselves. So in this case, it's going to be the integral from 0 to 2 pi of y, which is 1 minus cosine of t, times the derivative of x. The derivative of x is also 1 minus cosine of t, and that's dt. Okay, so we just have to multiply through. Let's see if we can do this. This is going to equal the integral of 0 to 2 pi of 1 minus 2 cosine of t plus cosine squared of t. Now, I don't know if you remember this or not, but we do have a power-reducing formula that we can use. That's supposed to be a cosine there. And the power-reducing formula is 1 plus cosine of 2t over 2. So if you weren't familiar with that, hopefully you recognize that, but that turns into that. And now I can integrate all of these things that you see here. And so I'll just go ahead and pound through this. This is going to be, let's see, t minus 2 sine of t is the antiderivative of 2 cosine of t. And then plus 1/2 of t, that's the 1/2 from this fraction, plus 1/4 sine of 2t. Because the antiderivative of cosine 2t is 1/2 sine of 2t, and then I still have the 1/2 from this fraction up here. And we're evaluating from t equals 0 to 2 pi. Almost done. Let's plug and chug. So upper limit is going to be 2 pi minus sine of 2 pi is 0, plus pi plus the sine of 4 pi is also 0, minus the lower limit, which is just a bunch of zeros. I'll just write it like that, but I guess there was a minus there. So the final answer is 3 pi. So it's kind of interesting that the area underneath this curve is 3 pi. There you go. Let me know if you need help with homework.